Hello everyone. So now I'm going to show you a tutorial how to access the software that we're going to use for the lab. The software is called Pspice software, which we could access it through our virtual network. So once you have access to the virtual network, all what we need to do, you need to go here to the start menu and you need to go to Cadence PCB and then click here on Capture CIS. All right, so this here version of the software is very new. So, but it works similar to the old versions, but with some differences. So let's see here, how can we run a simulation here? All right, we go then to File, then Start a new project. And of course, you could save it anywhere. So let's just give it a name and make sure that you enable Pspice simulation here. So just give it any name. Let's call it test 1, for example, and then OK. And then here you have to select create a blank project. So select the second option here, and then OK. What we are going to see here is like simple simulation for resistive circuit, like circuit that is just made of resistances. So let's say, for example, I want to have a circuit like this. Let's say I want to have circuit like, let's say, whatever circuit you want to make. Let's say this is 2K, this here is 1K, and this here is 5K, and I have a power supply here of 5 volt, for example. All right, and let's say I want to have let's make it simple. So I'm gonna erase this here to make it simple in the beginning. All right, and let's say we need to find the voltage and the current everywhere. So what should we do in order to do that? All right, so what we need to do here is the first thing we need to do is we need to add we need to add some sort of library. So this library here will allow us to add the parts we need, for example, resistors and the voltage source. So first you go to this icon we have here, place part, click on it. Then what you are going to see here, I don't have, for example, resistors, or I don't have voltage source. So all what I need to do here, let me move this a little bit here so we can see it better. All what I need to do here, I'm going to go here and add library. So this here will allow me to add a library that we need for the simulation. There are two main libraries here that we're going to need. One of them would be the analog library and the source library. So if you type here analog, and then click open, so that will add the analog library here. And if you go here, you're going to see the elements inside this. So you see the capacitors, and you're going to see resistors and so on. Also another library which is very important, which we call it the source library. So this also we need to add. So just to go here and write source, and you don't need to add them every time. So once you add it once, it should be there. If you write here source, okay, now you have the source library here, which allow you to get your sources. All right, so from the source, I need to have DC DC source, as we see here, which is the 5 volt we have here. So what we can do here is we could see this here. All right, so what we can do here, we can go to analog and just write R here. Now we're going to see this symbol here, R for resistor. The default value is 1K, as you see here. So, but we can change that. And also you could rotate this if you want by clicking R. So you could rotate it 90 degrees. So let's say I want to have this one here and then another one in the vertical position. All right, and let me zoom in so we can see it better. All right, so now we got the 2 resistors from here. Let's say one of them is going to be 2K. So this, instead of 1K, I'm going to have 2 and then letter K. And this one 1K, so I can leave it as it is. Then I need to add the voltage source, which is 5 volt. In order to add the 5 volt voltage source, you need to select the source, and then the voltage source 5 volt, the DC voltage source, usually we call it VDC. So this would be VDC, and here you're going to see the a picture of the voltage source and VDC. So just add it here, and then you will be able to connect all these elements using what we call here a wire, place a wire. So if you make place a wire, then go from here to here, and from here to here, and then from here to here. Now we connected all our circuit elements. We can now decide the value for the source. For example, here, if you want this value here to be 5 volt, I'm going to make it 5V with no space between 5 and V. So just 5V and OK. Now I assign 5 voltage here. All right, before running the simulation, you need to add a ground. Any simulation, like in Pspice analog simulation, you need to have the ground. The ground here is 0 capsum. So if you go here to this icon we have here, just to click 0 capsum, and you will be able to get this one here, the ground. And next you need to connect this ground also to your circuit. So just use a wire to do that. All right, make sure your wires are not loose. For example, if I drag this resistor up and down, I see that it's connected to the circuit. Same thing here. If you drag this here right and left, also make sure it's connected to the circuit so that you don't get error when you run the simulation. Now let's see how can we run the simulation for this. To run the simulation, we're going to go to this icon we see here, just to click on it, which says new simulation file, and then give it a name, any name, RRR, for example, just any name. And then now we have different kind of analysis here. The analysis we're going to use in the first experiment, we just call it bias point analysis. So just select bias point as we see here and apply. Then you click OK. Now that will allow you to run the simulation. To run the simulation, you need to click on this icon we have here, run Pspice. Now the simulation will run, and let's see what we will get. After it runs, another window will pop up as we see here, but you can go back to the schematic screen and you can see the result. All right, so what we are seeing here, we see the voltage and we see the current in the circuit. So the current in the circuit is going to be 1.667 milliamperes. And this would be the voltage at this point. So how to understand the readings here? Let's first, if you go up here, you just deactivate the voltage or deactivate the current or activate the voltage again. Let's see how to read the voltage we have here. 5 volt actually is, let me just do some annotation here. All right, the 5 voltage here is the voltage between this point to the ground, 5 volt. All right, so any voltage we see here is voltage difference between the point and the ground. Same thing here. The voltage here, 1.67, is the voltage between this point and the ground. All right, so that means the voltage across R2 is 1.667. All right, so what would be the voltage across R1? VR1 is going to be the potential difference. So VR1 here would be 5 minus 1.667. So that will give you the voltage across R1. All right. So the voltage we see here, this we call them nodal voltages. So it's from the point to the ground as we see here. All right. So this would be for the voltage. For the current, of course, in order to get the current I would be 5 volt divided by the sum of the two resistors, and that will give you the values of 5/3. So that will give you the value of the current. If you want to activate the current, so all what you need to do here is current display, and you will be able to see the current here. So the current here would be, if you divide this, you're going to get 1.667 milliamperes. Also, you can see the power in the circuit. If you click here, power display, you're going to see this would be the negative power because this is the source here, and the other power here. Of course, power, you can get it mainly by multiplying the voltage of the resistor times the current, V times I, and here also V times I will give you the power we have here, and then you could verify what we have here. So it does not matter how big or small your circuit, Pspice can still simulate it. So that was just a simple example with 2 resistors. But of course, if you have more resistors, you would be able to simulate it the same way. All right, thank you for watching, and please let me know if you have any questions.